Let us look at an example of sequencing n jobs on one machine. A printing press has 6 orders for printing. The table below shows the 6 jobs in the order of their arrival, their processing times, and due dates, that is days hence, of delivery to the customers. Sequence the given jobs according to the priority rules of first come first served, last come first served, due date, random, and shortest processing time. So basically this printing press has received 6 orders for printing. And this table shows the jobs in the order of arrival. What this means is A has been received first, then the order for B has been received, then the order for C has been received, and so on in this sequence. We have also been given the processing time in days, which means that this is the time it takes for each job to be processed. So for example, job A would need 3 days for processing, job B will need 7 days for processing, and so on. We have also been given the due date, which is days from the start. So from the start of the overall scheduling, A has to be delivered on the 9th day, B has to be delivered on the 10th day, C has to be delivered on the 7th day, and so on. Now with this information, we are being asked to sequence the given jobs according to the priority rules of first come first served, last come first served, due date, random, and shortest processing time methods. So let's see how we can achieve this. Now before we get into the details of how to solve this problem using the different priority rules, let us understand the concept of processing times and due date. So I'll pick up 3 jobs which have been given to us. So job C has processing time of 4 days, while the due date is the 7th day. Job D has processing time of 2 days, while the due date is the 4th day. And job E has a processing time of 5 days, while the due date is on the 8th day. So these are jobs. This is the processing time. And this is the due date. Now let us draw a time scale and try to understand the processing time and the due date. So let's say this is the start of the time scale, which is also the start of the time from which we are going to schedule these jobs. So this will be considered as day 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now the first job, which is C, has a due date of 7th day. So basically this is when this job has to be processed and delivered to the customer. While the processing time for this job is 4 days. So let's say that we start processing job C on the first day. It will take us 4 days to completely process job C. So 1, 2, 3 and 4. So fourth day is when job C will be completed. Similarly, for job D, the due date is the fourth day. So this is when job D is due to be delivered to the customer. While the processing time for job D is 2 days. So let's say we start processing job D after job C has been completely processed. So on the fourth day, we'll start processing job D, and then the processing will continue for the next 2 days. So 1 and 2. So the processing of job D will be completed on day 6. And similarly for E, the due date is the 8th day and the processing time for E is 5 days. Now in this example, we have been asked to sequence jobs A, B, C, D, E and F based on the different priority rules. So let us take the first priority rule, which is the first come first served method. Also known as the FCFS in short. Now in this method, the sequencing priority is assigned based on the sequence of arrival of the order. So what that means is that the order which comes first is processed first and the order which comes last is processed last. Now in this example, the jobs have been given to us in the order of arrival. So A has been received first, B has been received the next, and C has been received after B. So we'll note down the jobs in the same sequence because that is the sequence in which we'll process these jobs as per the FCFS rule. So jobs are A, B, C, D, E and F, and the processing times three days, 7 days, 4 days, 2 days, 5 days and 8 days, and the due date 9th day, 10th day, 7th day, 4th day, 8th day and 12th day. So now let us add another column for finding out the flow time. Flow time is the cumulative time period within which a job will be completed. Now, job number A is to be processed first and it is going to take 3 days for processing. So it will be over by the 3rd day. Now after job A has been completed, we'll process job B on the same machine. So it will take 3 plus 7, which is 10 days. For job C, it will be 10 plus 4, which is the 14th day. For job D, 14 plus 2, which is the 16th day. For job E, 16 plus 5, which is the 21st day, and for job F, 21st plus 8, which is the 29th day. So what this means is that job C will be done on the 14th day from the start of the overall scheduling. Job D will be done on the 16th day, job E will be done on the 21st day, and job F will be done on the 29th day. Now let us find out how many days late we are as compared to the customer's due date. So let's add another column, which is late by number of days. So job A was due on the 9th day and we'll be completing it on the 3rd day, so it is not late at all, so 0. Job B is due on the 10th day and we will be completing it on the 10th day, so this is also not late. Job C is due on the 7th day, but we'll be completing it on the 14th day. So 14 minus 7, which is 7, is the number of days by which job C has been delayed. Job D is due on the 4th day, while the flow time is 16 days. So the number of days late is 16 minus 4, which is 12. Similarly for E, 21 minus 8, which is 13. And for F, 29 minus 12, which is 17. Now let us take the average of the late by number of days to find out the average lateness. So 0 plus 0 plus 7 plus 12 plus 13 plus 17, and this divided by 1, 2, 3, 4, 5 and 6. So this comes out to be 8.1667 days. So this is the average lateness based on the first come first served method. Now let's move to the second method, which is the last come first served method. This is also known as LCFS, for last come first served. Now in this method, the dates are sequenced according to the dates of arrival. However, it is the reverse of the first come first served method. So the jobs which are received at the end is processed at the beginning, while the job received at the beginning is processed at the end. So now in this example we have been given the order of the jobs based on the sequence of arrival. So A was received first, B was received the next, and C was received the next. So let us note it down in the sequence of last come first served, which is F, E, D, C, B and A. Let us also note down the processing times. Eight, 5, 2, 4, 7 and 3, and the due date, which is 12, 8, 4, 7, 10 and 9. Now let's find out the flow time for this sequence. So job number F will be starting first and it takes 8 days to process. So job F will be finished by the 8th day. Now once job F is finished, job E will be processed. So E will start on the 8th day and take 5 more days. So E will be finished by the 13th day. Similarly, D will start on the 13th day and will take 2 more days. So it will be done by the 15th day. C will take 15 plus 4, which is 19 days. B will take 19 plus 7, which is 26 days. And A 26 plus 3, which is 29. Now let's find out the late by number of days, which is how many days are we late as compared to when it was supposed to be delivered to the customer. So F has a due date of the 12th day and will be done by the 8th day. So this is not late. E has a due date of 8th day but will be done on the 13th day. So late by number of days is 13 minus 8, which is 5. D will be finished on the 15th day but is due on the 4th day. So late by number of days is 11. C has a due date of 7th day but will be done on the 19th day. So 19 minus 7, which is 12. For B, 26 minus 10, which is 16. And A, 29 minus 9, which is 20. Now let us find out the average lateness. So 0 plus 5 plus 11 plus 12 plus 16 plus 20 divided by 6, which comes out to 10.667 days. So using the last come first served method, the average lateness is 10.667 days. Now let us move to the next method, which is the due date method. In this method, the jobs are sequenced according to their due dates of delivery. So the job with the earliest due date is scheduled at the beginning of the sequence, while the job with the next early due date is scheduled after that. So let us note down the jobs, processing times and due dates in the order of their due date. So D has the earliest due date, then C, then E, then A, then B, and then F. Let's note down the processing times. Two, 4, 5, 3, 7, and 8. Let's also note down the due date. 4, 7, 8, 9, 10, and 12. Now, if you note, these due dates are in the ascending order, so 4, 7, 8, 9, 10, and 12. Now let's find out the flow time of this sequence. So job number D will take 2 days to be processed. So it will be done on the second day. Job number C will start after D is complete, and then it will take further 4 days. So 2 plus 4, which is 6. So on the 6th day, job C will be completed. For E, 6 plus 5, which is 11. For A, 11 plus 3, which is 14. For B, 14 plus 7, which is 21. And for F, 21 plus 8, which is 29. Now let us also find out the late by number of days. So D is due on the 4th day and we'll deliver it on the 2nd day, so it is not late at all. C is due on the 7th day and we can deliver on the 6th day, so this is also not late at all. E is due on the 8th day, but we can deliver only on the 11th day, so 11 minus 8, which is 3. A is due on the 9th day, but we can deliver on the 14th day, so it is late by 14 minus 9, which is 5 days. B is due on the 10th day, but we can deliver on the 21st day, so this is late by 21 minus 10, which is 11 days. And F is due on the 12th day, but we can deliver on the 29th day, so this is late by 29 minus 12, which is 17 days. Now let us find out the average lateness. So 0 plus 0 plus 3 plus 5 plus 11 plus 17 divided by 6, which is equal to 6 days. So average lateness based on the due date method is 6 days. Now let us move to the next method, which is the random method. In this method, the jobs are selected for processing at random by the workers. So let us look at that method. So as I mentioned, in this method, the jobs are selected for processing at random by the workers. Hence, the processing sequence may vary from individual to individual depending on who is selecting the jobs. So let us pick up any sequence. So we have jobs, and let us pick a random sequence. So we'll process B first, then F, then D, then A, then C, and then E. Let us also note down the processing times. So B takes 7 days, F 8, D 2, A 3, C 4, and E takes 5 days. Let's now note down the due date. So for B, it is the 10th day. For F, it is the 12th day. For D, the 4th day. A is ninth day, C is 7th day, and E is 8th day. This is 12. Now let us calculate the flow time. So we'll first process B, and B takes 7 days, so B will be done by the 7th day. F will take 7 plus 8, which is 15. So on the 15th day, F will be processed. D will be processed on 15 plus 2, which is the 17th day. A will be processed on the 17 plus 3, which is 20th day. C will be processed on 20 plus 4, which is 24th day. And E will be processed on 24 plus 5, which is 29th day. Now let us find out the late by number of days. So B is due on the 10th day and we'll be able to deliver on the 7th day, so this is not late. F is due on the 12th day and we'll be able to deliver on the 15th day, so this is late by 15 minus 12, which is 3 days. D will be late by 17 minus 4, which is 13 days. A will be late by 20 minus 9, which is 11 days. Now C will be late by 24 minus 7, which is 17 days. And E will be late by 29 minus 8, which is 21 days. Now let us find out the average lateness. So this will be 0 plus 3 plus 13 plus 11 plus 17 plus 21 divided by 6, and this comes out to 10.833 days. Now let us look at the fifth method, which is the shortest processing time method. Also known as the SPT method. Now in this method, the priority rule of sequencing is based on the processing time of the jobs. The job with the shortest processing time is scheduled first, and the remaining jobs are sequenced according to their processing times later on. So basically, the job with the highest processing time is scheduled at the end of the sequence. So let us note down the jobs in the sequence of their processing times, starting with the lowest. So D has the lowest processing time, then A, then C, then E, then B, and then F. And let's note down the processing time for these jobs. So 2, 3, 4, 5, 7, and 8. Let's also note down the due dates. 4, 9, 7, 8, 10, and 12. Now let us find out the flow time. So D will be processed first. So it takes 2 days to process D. So D will be completed by the second day. A has a processing time of 3 days. So 2 plus 3, which is fifth day. C will be 5 plus 4, which is ninth day. E will be 9 plus 5, which is the 14th day. B will be 14 plus 7, which is the 21st day. And F is 21 plus 8, which is the 29th day. Now let us find out the late by number of days. So for D, the due date was the 4th day and we are going to deliver it on the 2nd day, so this is not late. For A, the due date was 9th day and we are delivering on the 5th day, so this is also not late. For C, the due date is the 7th day but we'll deliver on the 9th day, so this is late by 9 minus 7, which is 2 days. E is late by 14 minus 8, which is 6 days. B is late by 21 minus 10, which is 11 days. And F is late by 29 minus 12, which is 17 days. Let's find out the average lateness. So this will be 0 plus 0 plus 2 plus 6 plus 11 plus 17 divided by the number of jobs, which is 1, 2, 3, 4, 5 and 6. So this comes out to 6 days. So this is the average lateness based on the shortest processing time method. So we just saw 5 methods of sequencing n jobs on one machine. Now let us find out which job is the best for us in terms of average lateness. So the first method, which is FCFS, had an average lateness of 8.17 days. The second one, which is LCFS, has the average lateness of 10.67 days. The third, which is due date, had an average lateness of 6 days. The fourth, which is random, had an average lateness of 10.83 days. And the fifth, which is the shortest processing time method, had an average lateness of 6 days. So basically, the lesser the lateness, the better the sequencing is. So due date and the shortest processing time give us the best results in this case.